Here we're going to talk about principles of relational modeling, and this is following along with how to create design relational models. And there are a lot of rules here, and it takes a little time to get a hang of it, but you get it after a little while. So each class, once again, also known as entity, refers or should refer to a unique entity, concrete or abstract. So you got to be careful with this. People have a hard time working with abstract concepts, but they may exist. So we may have tables about agencies, but also tables about processes, tables about things like enrollments, and so on, transactions, and so on. This class will be a single table. So that is, each particular class like this is going to be translated into a table when we actually implement it into a database. Each class or entity has at least one attribute, usually more. So a class without attributes doesn't make sense. We probably don't need it. So the class is kind of defined by its attributes. And usually one, but usually more. If you just have one attribute, you might consider putting your attribute in another separate table, in another separate class. Each class needs a primary key to uniquely identify its record. So if you don't have an attribute that can work as a primary key, you need to make one up, like a auto-generated, auto-incremented unique ID. Each attribute needs a specific data type. The data type is important, so that's why I like to determine on the model itself. Sometimes if you design it, you don't have to add it. So before I kind of had some things here, see, there's no data type here, but that's no good because we need to determine that. So we might as well write it in our blueprint in our model. The value for each attribute should be the smallest useful unit. So here is not a good example. So I just have a name for the agency. Well, actually for the agency, maybe you just have a name. There is no, usually we don't have name, like an agency doesn't have last name and first name, but usually we want to break those down to the smallest useful unit possible. So for example, the address, we break down the address into address and city and zip, not just all one long address. Keep the attributes of each entity in their own class. And this is kind of the hardest part, and it really takes a while to get a hang of it. So for example, supervisor phone number should be listed under the supervisor, not the employee class. And actually, this is an interesting example here, and I did this on purpose. If you notice, I started putting attributes of the state itself in the agency's class. So we do need to put the state code here, as we talked about before, because that links this table with the states table, the table of information about the states. But all the information here, state name, state region, these are attributes of the state. Because these are attributes of the state, we do not want to put them here. We just want to put them on the state's agency, on the state's table. So we need to remove these from here and leave them here and add them here. We already have the name here, state name, and the state region might be here as well. So this is not necessary. Not necessary. The only one we need is this one here. And it kind of makes sense because this is an attribute of an agency. An agency is going to have a state. We just don't need to keep adding additional attributes of the state here because they're recorded here. And this is how we keep the database efficient. Student example with full cardinality and associative entity. So we kind of went over that. Some more data modeling requirements. So to actually design a data model like we did here regarding students and courses, or how we're going to keep the information about the agencies and state information if you are working in that kind of context. You need to understand your business, you need to understand your organization, you need to understand the task requirements. You need to understand the users of the system, who are the users, what kind of users are there. You need to understand the use case scenarios, so how individuals interact with the system, what do they do, in which occasions do they interact, and for which purposes. You need to understand the current and potential future uses of data. So how are people going to use data today? How are people going to use data tomorrow, and so on? You don't want to have to keep changing the structure of the database because it takes time and effort to create them. It's also important to understand the primary data versus the secondary or calculated data. So some information we need to capture from directly from the user, from the application, or from the transaction. But other data, other attributes may be calculated or inferred from the primary data. And we will use some examples of this when we're talking about querying the database. So this is kind of important to understand as well. So there is no duplication and you don't need to, you understand what data needs to be captured and what data can then be just calculated from the existing data. Steps for creating a relational data model. So here's a simplification of some steps that we need to take to create a relational data model for a particular problem or occasion or task. So often what we're going to do is we're going to list the potential entities that must be captured. Maybe the states, we need state information, we need agency information, and so on. An entity is equal to a class. Once again, just repeating myself, an entity may refer to a concrete thing, a process, an interaction, or an event, or other entities, all the kinds of entities. List the attributes of these entities. This is an iterative process of examining the entity and the attributes. Add the proper attributes to entities, considering primary keys and relationships among entities. Once you determine those, the foreign key is the primary key repeated in 2 tables, right? And as I mentioned before, use the PK from the one side and repeat it in the many side. Consider normalization. We're not going to get to this in this course, but you will learn this in the more developed specific database class. But essentially is we want to create classes where all of the attributes in a class are attributes of that class only and not of another class. And this has to do with what I just talked about, the state information in the agencies table. We want to keep that information. We want to keep the state information in the state table. Just keep the agency information in the agency table. This is not always possible or advisable, but it is generally recommended. And here I kind of already went over it. I left it here, but this has to do with the state name. If you start putting state name here, sometimes you don't know. I made it obvious because I wrote state name and state region. But sometimes you're just thinking of the region of the agency, and should that be in this? If it's a region of the agency, then you put it for agency. But if it's the region of the state, then you leave it under the state table. Okay, so here we have a practice scenario. Suppose you are working for a client to develop a database system. Based on the description below, develop an initial data model for the system. And here's the description. So the client is telling you, we are in the book lending business, and the patrons or our customers come to our shop and look to borrow books. We need a database system that keeps tracks of the books and the patrons and the loans we give. We need to know when loans are due, as we need to send reminders to the patrons to bring the books back. So we need to keep that information. In addition to books, we also lend DVDs, laptops, or other resources such as headphones, and we want to keep information about that as well. We want to keep track of all of this information. So here you can pause and start designing your model yourself. I left the description up top to help us. What I'm going to do is I'm going to start a data modeling exercise to show you how to get started. But you should pause and try this yourself first. So I see that I'm looking for, first we're going to look for entities. And maybe it's clear, maybe it's not, but I see patrons. So we have patron. I see books. I see loans. And I see maybe other things like DVDs, laptops, and other accessories, resources, other maybe resources in general. So here we begin identifying the entities. And then from each, and then you may have to go back. The example might be clear or not, more or less clear. And then you say, okay, this is an entity. So we even start drawing the square of, and then you write out, okay, this is going to be the patron class, the patron entity. And then what attributes? Well, they're actually not talking about attributes. So you kind of need to sort of determine, and often there is information, they usually will tell you more information, but you can kind of guess. So we're going to have name, we're going to have address, we're going to have phone, and email, and so on, and maybe others. We're also going to need to determine the data type. Name, well, this is usually going to be character because these are text-based, like letters. Address is also character. Phone, character, not integer, right? You might have dashes and so on. This is not an integer number to calculate. This is really character. Emails, characters as well. Maybe date of birth. Who knows? Date of birth. That's going to be date. Date is another native data type, so date. And you begin the process this way. Now, it's very hard for me to write here on the screen, so forgive the handwriting, but you start noticing, okay, well, we need to determine a primary key, as we kind of mentioned before, right? To go back to the rules, we need to determine primary keys. And you're like, well, primary key, what's the primary key? Well, name cannot be because there's too many John Smiths around. So it's not going to uniquely identify anything. So maybe we need to create a unique patron ID. How about that? Yeah, we're going to have a patron ID. The order doesn't matter. Patron ID, and that's going to be an integer because that's just a number, long number, integer. And then so on. And then we can also write that this is, I usually like to write it over here, but we can kind of write it outside because I don't have any space. Primary key. And you may think, well, what's the relationship between the patron and the book? So we're going to have a table. Well, first of all, let's get the book entity drawn out. And there's a book title, there's call numbers, there's author, and there's a bunch of other stuff. You start listing all the stuff that's necessary and the data type, and you identify the primary key. And then you're thinking, okay, is there a relationship between patron and book? Are these connected? And if you start thinking about it, they are, in a way, they are connected, and we can draw it out and say, okay, each page, what is this? One to many, one to one, or many to many? And we think about it. Each patron can borrow how many books? Well, they can borrow many books, actually. Each patron can borrow many books, one or many, or zero or many. Each book can be, the same book can be lent to how many patrons? Oh, many. The same one book can be lent to many patrons. Not at the same time, but over time for sure. And you see, oh, this is a many-to-many relationship. Now, we cannot really implement many-to-many relationships in data RDBMS. We need to break them up and create an associative entity. That's the rule. You break up the many-to-many and create an associative entity. So, and it just so happened that what is the associative entity? The associative entity here in this case is the loan entity itself. So the loan is the thing that connects the two. And actually we can break this up and think of these, think of these as one to many. I prefer this notation better. One to many. One patron can have many loans, but each loan refers to the one patron, right? Each loan is only referring to one person. It could be that one loan could have many people, two people borrow the book at the same time, but we don't want to do that. We want to enforce Each loan has to be only one patron. And actually, this is the opposite here. Each loan can have many books, but each book can only have one loan. No, this is wrong. Each book can have many loans, not at the same time, but over time. Each loan, though, only refers to one book. If a person is borrowing multiple books, that's multiple loans. So loan, what are we going to have? Well, we're going to need a loan ID like everything else. And then we're going to have the book ID from the book table. This right ID, and this is going to be PK, right? And then we're going to have the patron ID. So this is going to be the PK here. We're going to have the book ID and the patron ID, and these are going to be the foreign keys that link this table with this table and the book with the loan and the patron with the loan. So these are going to be the foreign keys because, and you can see that we're taking the primary key from the one side and put it in the many side. And we're taking the primary key here of the one side and also put it in the many side. Primary key of PK of one side and put it in the many side. And that's how we do it. And then, of course, you may see, well, there's all the information here about the loan that we want to keep, like when was it loaned, the date that was loaned, the date that is due, maybe the date that it was returned. Maybe there's all the information here as well. And maybe there's all the more information for the patron and maybe more information for the book that you need to keep. But I think this really gives us a good start into data modeling for relational databases. And I'm going to show you next time how to implement this database and manipulate it. See you next time.